Okay, so today we're going to continue with our atomic theory and how the idea of the atom was developed. And as you saw last time, we heard about what Lavoisier and Proust did to get us started with the idea of the atom. These guys came up with the conservation of mass and the fact that all compounds have, for that particular compound, a specific and unique formula, a particular mass ratio of the elements that make up those compounds. And so we get now to John Dalton. John Dalton's an Englishman who was very interested in the solubility of gases. And so one of the things that he was doing is he was trying to figure out how is it that you can dissolve gas into a liquid if the liquid is in fact continuous, like people thought. Then there's no space, there's no empty space in there to allow for the gases to come in. But instead, he thinks, what if the liquid has hollow spaces, that is made out of individual particles, and there are hollow spaces in between. There's a void or empty space. Well, if you have a small gas, you can put several of those small molecules into those empty spaces and you can dissolve more of the gas. If you have a larger gas, maybe sometimes it's more difficult for that gas to fit, and so fewer of those molecules would fit in. And so based on his idea, his research into the solubility of gases and reading about everything that had come before him, Dalton is going to create his own atomic theory. So he's going to put all of these ideas that are brought from Lavoisier and Proust, and even some of the ideas that came from the ancient Greeks. All right, and he's going to develop his own atomic theory. And he's going to base it on 4 postulates. All right, 4 basic pillars, if you wish, on which he is going to be talking about the atom. All right, the first thing that he says is that, in fact, all matter is composed of atoms, which are going to be these tiny, indivisible, solid spheres. So he thinks of the atom as these spheres that are just solid and not made out of anything else but the atom. Clearly, from the 21st century perspective that we have, we know that this is not true, and yet it's revolutionary because he starts giving us this idea. Where does he get that? He gets it both from his own work, trying to make sure that he can explain how gases dissolve into a liquid, but also from the idea that the Greeks had come to give him. The second thing that he says is that all atoms of the same element are identical in all of their properties and different from atoms of different elements. All right? Now, that sounds interesting, but how did he get to that? Well, if we have a compound and we talk about the molecule of water like we had been talking before, all right? You remember that water is composed of 1 atom of oxygen and 2 atoms of hydrogen. Well, if the mass ratio is constant, it means that the hydrogen here or in China or in the moon have to have the same composition, the same properties to bind exactly the same way to oxygen, and that the oxygen also has the same mass everywhere, and so you can keep that mass ratio constant. That comes then mostly from Joseph Proust. The third postulate that he gives us is that compounds are made by combinations of different atoms in integer ratios. The short is, if he said that atoms are indivisible, you cannot mix atoms in fractions. You have to have a whole atom. So that's obviously why we have the idea of the word integer. All right? And you have to have combinations of different elements in order to make the atom. To make a compound. So again, this comes mostly from Joseph Proust, all right, and his own personal research. The final idea that he comes up with is that atoms are not modified in chemical reactions, only rearranged. That we can see comes from the ideas of Lavoisier. Why? Because in a chemical reaction, Lavoisier saw that the initial mass and the final mass were the same, that you were not changing that property. And that was one of the most important properties that they knew about elements at the time. And Dalton realizes that in fact the way to maintain mass is for every atom to always keep its identity. If an atom of oxygen cannot be changed into an atom of nitrogen, then the mass of the oxygen will always be constant and you're not modifying that atom. Okay? Now, there's one problem. There's one big problem with the Dalton model. All right? What do you think it is? What is the biggest problem that you can think for the Dalton model? From the Dalton model, what do we know about the atom? The atom has to be indivisible. And that is going to pose a problem. So, we know, again, from the 21st century, that the atom is not indivisible, that there are smaller things that make up the atom. All right? Here we've got just some of Dalton's old formulas, and we can see just some beautiful examples of how he drew his atoms and all these kind of things. But each atom was solid. Each atom was composed of only one particle, that atom itself. And that cannot explain many of the results that came later. Guys like Franklin, Faraday, and Humphrey Davis were all interested in the idea of electricity. All right? And you know that matter can be either neutral. Most of matter around us is neutral. It can be positively charged or negatively charged. Now, if I take two different substances and I rub them together, all right, I can get them to charge. When have you seen that? You've seen that when you, for example, rub a balloon on somebody's hair. So, as we were saying, if you have a balloon and some hair, for example, here we have Fluffy, and you rub them together, both the hair and the balloon are going to become charged. And how do we know that? We can demonstrate that by seeing how the balloon now attracts a very light ball, and that attraction occurs because it is charged. All right? Now the balloon was not charged to begin with. And so if the balloon was not charged, whatever made it charged must have come from the hair, or whatever, we've transferred somehow part of the balloon or part of the hair from one side to the other. That means that in fact we have to have parts to the atom. We have transferred bits of the atom from going from one side to the other to cause charge. Therefore, that requires us to see that electricity is caused or can be thought of as a fluid, something that is transferred from one substance to another. We know, again, that that is because of electrons. Yet, in the time of Franklin, he did not know that. So, he just knew that it was some type of fluid, something that could move. This is the big problem with the Dalton atom. The Dalton atom required the atom to be solid and indivisible. Yet, the fact that the atom can be electric, that can be charged positively or negatively, means that there are subatomic particles that make up this atom. So we get to J.J. Thomson. J.J. Thomson is going to do some excellent experiments, and he's going to demonstrate one of the important things about the atom. J.J. Thomson will give us much more information about the electron, and we will see that in our next podcast. Till the next time, I want you to think about what are the requirements. How is it that in fact you can have two neutral substances, and after rubbing them together you'll get a negatively charged one and a positively charged one? what must happen, what must be part of the atom if you're going to get a negatively charged substance and a positively after you rub them together. All right, write down your answer to that question in your notebooks, and I will be checking that next time. Thank you.